This lesson I want us to check the hyperbolic function. So the general formula for this function is given by y is equals to a over x minus p plus q. So when we check on the coefficients or the constants that are in this formula, the value of a determines the shape or the position of the graph. So if a is greater than 0, if a is positive, then our graphs will be in the first and the third quadrant. And then if a is less than 0, whereby a is negative, then on your Cartesian plane, your graph will be in the second quadrant and the fourth quadrant. Then now we also have the value of p and the value of q. So the value of p and the value of q determines what you call the asymptote, whereby we know that an asymptote, we denote it by a dotted line on the graph, and the graph will forever approach that dotted line, but it will never touch that line. So p represents the x asymptote, and then the value of q determines the y asymptote. Meaning that p as our x asymptote, when we do it on this graph, we know that it will be our vertical asymptote. It will be a line cutting on the x-axis, just like this. And then the value of q, which is our y asymptote, or we can call it the horizontal asymptote, it will be like this on a graph. Then these are our asymptote. So in order to find the exact value of p, you have to take whatever is in the denominator and equate it to 0, and then solve for x in order to find the x asymptote. So you're going to say x plus p is equals to 0. This is subtraction. So it means x minus p is equals to 0. And then when we make x the subject of the formula, we're going to have x is equals to p. So this p is our x asymptote. And then the value of q is our y asymptote. So it meaning that y must be equals to q. For an example, if you are having an equation like this, f of x is equals to 2 over x minus 1 plus 3. Then they want you to write down the equations of the asymptotes. Then in order for you to find the x asymptote, you have to say x minus 1 is equals to 0. And then your x asymptote is 1. And then your y asymptote, we know that y must be equals to q. Then y is equals to q. Then it means y is equals to 3. Meaning that this is your x asymptote and this is your y asymptote in that order. Then the other thing that I want us to check is what we call the axis of symmetry. We know that when we talk of the axis of symmetry, it's a point whereby we have to divide the graph into two equal parts. So knowing that a hyperbola has two half graphs in order to complete a single hyperbola, for us to divide these into two equal halves, or for it to have a point of symmetry, we can choose to have a point of symmetry here, whereby we know that this line will divide the graph into two equal parts, or we can divide this graph in this way, whereby our graph is still divided into two equal parts. So observing from the left towards the right of the red line, we can see that the slope or the gradient of this line, of this red line, is decreasing, meaning that the gradient of this red line is negative. We have a negative gradient here. But the gradient of this purple line, observing it from the left towards the right, then you can see that we are having a positive gradient here. So it's either we can divide this hyperbola graph into two equal parts by using a negative gradient or a positive gradient. So the equations of this axis of symmetry on a hyperbola, we know that it is noted in this way. For a negative gradient, okay, let's start with a positive gradient. For a positive gradient, we know that the equation for a straight line, because you can see that this is a vertical line, or rather a straight line which divides this graph into two equal parts, then we know that the equation of a straight line is given by y is equals to mx plus c. But in this case, our gradient will forever be 1. Our slope for this line will forever be 1. All right. So in this case, for the axis of symmetry, the equation for the axis of symmetry of a positive gradient, then we know that it should be y is equals to x plus c. This is for a positive gradient. And then for a negative gradient, we say y is equals to negative x plus c. So these equations, you should try to memorize them because they are not there on the formula sheet. So these are the two formulas for the axis of symmetry. So if they want the axis of symmetry, whereby they tell you that the other asymptote is decreasing, you know that you're going to use the one for negative gradient. But if they tell you that you must look for the axis of symmetry, the equation of the axis of symmetry, whereby the other asymptote is increasing, then you're going to use the one for positive gradient. So in order to obtain the value of c, because you know that in order to complete an equation, we must have, maybe for an example, y is equals to x plus 2. So in order to find the value of c, you are going to take your asymptotes, your x and your y asymptote, and then put them in coordinate form. For an example here, if we wanted to find the equation for the axis of symmetry of this asymptote, we're going to say our x asymptote, we know that it's 1, and then our y asymptote is 3. So suppose one of these asymptote is decreasing, so we want to find the equation of axis of symmetry for a decreasing function. Then we're going to take this formula and then say y is equals to minus x plus c. Then in order for us to find the value of c, we're going to substitute the asymptotes on this equation. This is our x and this is our y. Where we see y, we put 3, then this is equals to negative, and then we're going to put 1 plus c. Then we do math, this one goes to the other side, it becomes positive. It means we're having 3 plus 1, which is equals to c. Then 4 is equals to c. So it means the value of c, it's 4. Then we bring back the value of c to the original formula. Therefore, our equation now becomes minus x plus 4. So this is our equation of the axis of symmetry. This is how we can try to find it. So when you are done with this, they can say to you, determine the domain and the range of a hyperbole. All right. So to determine the domain of this graph, we say that x must always be a real number, but x must never be equals to the x asymptote, because we know that where there is an asymptote, that is where the graph is not defined. So at the asymptote, our graph is undefined. But if for every x value on this graph, then the graph is defined. So x is the element of real numbers, but x must never be equals to our x asymptote. Then for the range of this graph, we say y is the element of real numbers, but y must never be equals to the y asymptote. So even for y, for every possible y value, the graph is possible, but on the asymptote, on this horizontal asymptote, then our graph is not possible. So this is how you can write your range and your domain. Or someone can choose to say on the domain, we can say that x is the element of from negative infinity to infinity, but our x must never be equals to our x asymptote, which is the value of p. Similarly, for the range, we can use the same format by saying y can be the element of from negative infinity to infinity, but the y value must never be equals to the y asymptote. So this is how you can choose to write your domain and range. You can choose to write it this way, or you can choose the second one. Okay, so in this hyperbola, you must know how to sketch the graph, and then you must also know how to interpret this graph. All right, so now I want us to check a question whereby we will be sketching a graph, and we must know the procedures that are need to be taken in order for us to be able to draw a graph. All right, let's check on this question. We're given a function f of x which is equals to 2 divided by x plus 1, then subtract 3. So the aim of this question is for us to be able to sketch the graph of f on your answer book by showing the asymptote of the graph and all the intercepts. But before you can sketch, we have to know that in order for you to sketch a graph, we must find the x-intercept, the y-intercept, and the asymptote of this graph. So the first question says, calculate the coordinates of the y-intercept of this function, then the coordinates of the x-intercept, and then we can sketch the graph. So feel free to pause this video and then try this question on your own, and then you can check the solution when you're done. All right, so let's do the first question. They want us to calculate the coordinates of the y-intercept. So we know that for y-intercept, we're going to let our x value to be equals to 0. So remember, f of x is just a notion or a notation whereby this is y. All right, so it means we're going to say y is equals to 2 divided by x plus 1, then minus 3. All right, we said we're going to let our x value be equals to 0. Then it means we're going to have y which is equals to 2 over 0 plus 1 minus 3. And then this is 2 divided by 1, which is 2, then minus 3. Then our y value now becomes negative 1. Because they said they want the coordinates, we have to put this in coordinate form. We know that when x is 0, our corresponding y value is -1. And then we are done with our y-intercept. And then the second question says calculate the coordinates of the x-intercept of f. Then it's 4.1.2. We know that when we calculate the x-intercept, we let our y value become 0. So now it means we are going to have 0 is equals to 2 over x minus or plus 1 minus 3. So in order for you to be able to solve this, we have to take this 3 to the other side. Then it becomes positive. It means we're going to have 3, which is equals to 2 over x plus 1. And then now we must remove the fraction. By removing the fraction, we multiply both sides by the denominator. So meaning in the next step, you're going to have 3 into x plus 1, which is equals to 2 over x plus 1 multiplied by x plus 1. What you do on the left hand side, you also do it on the right hand side. Then this one divides this one. Then on this side, we are left with 2. Then when we multiply here, we're going to have 3x, then plus 3. Then this becomes 3x. Then we take this 3 to the other side, and then we're having 2 minus 3. Then we're going to remain with -1 this side, then 3x. Then we can divide by 3. We can divide by 3. Then x is now our subject of the formula, which is equals to -1 over 3. Then when we write it in coordinates form, then we know that our x value is -1 over 3. Then our corresponding y value is 0. Then we have answered number 1 and number 2. So in order for us to be able to sketch this, they want you to show the asymptotes and the intercept. We already have the intercept of this function, but we don't have the asymptote. So for the asymptotes, we know that we are going to have the x asymptote and the y asymptote. Then our y asymptote is this value here together with its sign. So it means our y asymptote is -3. And then our x asymptote, we are going to take whatever is on the denominator and then equate it to 0 and then solve for x. Then it means our x asymptote becomes -1. Then these are our asymptotes. So our asymptote in this case is -1 and 3. Then in this case, now you can sketch your graph, right? So let's try to sketch this graph. Let's try to sketch this graph. These are the x-axis, these are the y-axis. So our x asymptote is -1. So it means we will have a dotted line at x is equals to -1. At x is equals to -1, it can be a point around here. So this is our x asymptote. Then you can write this is x is equals to -1. And then we also have our y asymptote at y is equals to -3. Then it can be a point here, a horizontal line here. Then we can say this is y is equals to -3. Then we have drawn our axis of symmetry or our asymptote. All right, then we can now plot our points. We have our y-intercept as 0 is to -1. So this is 0 is to -1. When x is 0, then our y value is 1. It can be a point around here, and then this is a point 0 is to negative 1, and then our x-intercept, we know that for the x-intercept we're having negative 1 over 3 is to 0, which is a point here, because negative 1 over 3 is negative 0.3, then it can be a point here. Then now we just need to join our graph. Remember, the graph will approach the asymptote, but it will never touch the asymptote, just like this. And then if your graph is like this, your x and your y asymptote, or your x-intercept and your y-intercept are already plotted on one graph, then here you just do the reflection of this piece of a graph, then in order to complete your graph. So you do this, and then now this is your graph of f of x. Then now this is how your graph should be. Then now you have sketched the graph. Then the last question says, one of the axes of symmetry of f is a decreasing function. Then write down the equation of this axis of symmetry. Remember, when we talk of a decreasing function, and they are talking of the axis of symmetry of a decreasing function, we decrease from the left towards the right. So it means they're talking about this line here. This is a decreasing function. So they want you to determine the equation for the axis of symmetry for a decreasing function. So if they told you about that situation, you are going to say y is equals to negative x plus c. So this represents an equation or a straight line equation for a decreasing function or for a negative slope. Then now we are going to take your coordinates of your what? Of your axis of symmetry or your asymptote, which is negative 1 and negative 3. And then we're going to substitute them here. Where you see x, you're going to put negative 1. Where you see 1, y, you're going to put negative 3. Then it means you're having negative 3, which is equals to negative into negative 1 plus c. Then it's negative 3, which is equals to 1 plus c. Then when we take this 1 to the other side, it becomes negative, and then we're having our c value, which is equals to negative 4. Then we take the c value and then we substitute it back to the original. Then it means y is equals to negative x minus 4. So this is the equation for the axis of symmetry for a decreasing function. So in that way, we have answered all questions. So if there is something that you don't understand, you can post it in the comment section. And I hope everything makes sense. And then we can look on another example or another question whereby we will be interpreting the graph. Here is another question. A sketch of a hyperbola given by the function f of x is equals to x minus d divided by x minus p, where d and p are constant. It's given below. So this is the sketch that they are talking about. So the dotted lines are the asymptotes. Then the asymptote intersect at p, which is this point here. You can see that the vertical and the horizontal asymptote intersect there. And then we're given the coordinates of p, which is a point of the function of f of x, whereby it's given by 2 is to 0. And we can see that that is the x-intercept. Then the first question, or let me show you all the questions. So if you feel like you want to try them before we do the solution, then you can pause the video and then try them by yourself. So the first question says determine the values of D and P. The values of D and P. So let's look at our graph. From the graph, we notice that we're given a point which is B, and we also have a point P, which is the intersection of the asymptotes. But we also notice that we're given a value here which is -1. So this value here of -1, this is the value for the vertical asymptote, which we know that the vertical asymptote is the same as they're saying x is equals to -1, because we can see that this -1, it's on this vertical asymptote, whereby we can see that on the Cartesian plane, this line cuts on the x-axis. So we already have the value for the asymptote, for the the vertical asymptote. So from our function f of x is equals to x minus d, all divided by x minus p. Remember, the original function, or the default one, we know that this is a over x minus p plus the value of q. All right, whereby we know that the value of p and q are our asymptote. Then q is our y asymptote, and p is our x asymptote. So in this case, we already have the value for the x asymptote. Then our x asymptote is negative, it's -1. So we know that the value of p is -1 in this case, because in the denominator, the value of p, that is where we find the vertical asymptote. So the value of p, we can see that it's -1. So the value of p is equals to -1. Then how do we find the value of d? So to find the value of d, we can use this point on this graph, which is point B, and then we can substitute it and then find the value of d. So now we have f of x, which is equals to x minus d divided by x minus p. So we already know the value of p, which is -1. Then we're going to substitute it here. We know that this is x minus d, and then this is x minus into -1, and then we have x minus d divided by x plus 1. And then we use point B, which is 2:0. Then we substitute it here on the equation. So meaning that when we see x, we substitute it by 2, then our y value is 0. Then we're going to say 0 is equals to 2 minus d divided by 2 plus 1. Then on the denominator, we have 3. Then we have 3 here. All right. Then we multiply both sides by 3. Then we're going to have 0 is equals to 2 minus d. Then the value of d now becomes 2. So we have determined the value of p and the value of d. So the value of d is 2, and then the value of p, we know that that is -1. So we have answered the first question. Then now they say to you that show that the equation of f of x can be written in this form. Then in order for you to be able to write that equation in that form, we know that we're going to substitute the value of d here. Then our function of f of x, we know that this is x then minus 2 divided by x plus 1. So this is our equation of f of x. They want you to write the equation of f of x in terms of f of x is equals to a over x minus p plus q. They want you to change the format from this to this original format. All right. So for you to be able to answer that question, you have to do this. We say that y, or you can say f of x is equals to, then this is x plus 1. Then on the numerator, you also write x plus 1. And then you put 1 here. And then now we going to check on what is on the numerator. When you multiply here, you're going to get x. Or let me use a different color. When you multiply here, you're going to get x. Then 1 multiplied by 1, you're going to get positive 1. But you can see that this is not equivalent to this one. So in order for us to have x minus 2, we have to subtract 3 here. Because if we subtract 3, we're going to have x minus 2. So it means this equation needs us to subtract 3. You see? So now, because our aim was for the 2 to be able to cancel out, now we have to subtract 3 in order for the numerator to be able to be equal to this one. Then in this case, we are having a fraction. We know that if you are having a over b minus c, you have to find the LCD, and then which is will be b. Then even here we're going to divide this one by x plus 1, and then this one and this one will cancel out. Then our equation here will be y is equals to, then we're remaining with 1 because the 2 cancel out. We are remaining with 1, then minus 3 over x plus 1. Then you can put it in a standard form. Then we're going to have negative 3 over x plus 1, then plus 1. So you can see that this is what they were looking for. We can try that again with a different example. So let's suppose you are given h of x, which is equals to 2x plus 1 divided by x minus 2, for an example. All right. So they want you to change this form to h of x is equals to a over x minus p plus q. Then what you're going to do, you're going to say y is equals to, the first step, you write down the denominator, and also on the top you write the same thing. All right, our denominator and numerator must be the same in order for them to be able to cancel out. Okay, and then now we bring in multiplication. So in order for us to have 2x, we have to put 2 here, so that when we multiply here, we are having 2x. Then 2x multiplied by a negative 2, we have minus 4. So this is what we get when we multiply the numerator here. But the numerator here that we got here, it's not equivalent to this one. So in order for them to be equivalent, we can see that we need to add, because this is 2x plus 1. So 2x, we already have it, but here we are having negative 4. So in order for us to have 1 here, we must add 5 in order for the sum to be 1. So it means we must add 5 here. Then when we add 5, we know that it's the same as saying y is equals to 2 into x minus 2 divided by x minus 2 plus 5 divided by x minus 2. Then this one will divide this one. then your y value now becomes 2 plus 5 over x minus 2. Then when you put it in standard form, it's going to be 5 over x minus 2 plus 2. Then this way it's written in the form of a over x minus p plus q. I hope it makes sense. I hope you understand how we change the form of this hyperbolic function. So now they want us to write down the coordinate of P. The coordinate of P. Remember, P is a point of intersection of the asymptotes. Alright? And we already know the x asymptote, which is -1. We are missing the y asymptote. But since we wrote our function in this form, we know that our y asymptote is this value here. So the coordinate of P is -1 is to 1. Then we are done with that question. Then the last question says, write down the coordinates of the image of B, of this point B, if B is reflected about the axis of symmetry, y is equals to x plus 2. So we're given an axis of symmetry. Which is y is equals to x plus 2. Then when we try to sketch that, we can see that our gradient is positive. So x plus 2, when we find the y-intercept of this, we let x be equals to 0, then our y becomes positive 2. Our y becomes positive 2, which is a point maybe here. And then our x-intercept, it's -2, which it can be a point here. So the axis of symmetry that they're talking about, it's a line here. This is the line of the axis of symmetry. So they want you to write down the coordinates of the image of B if B is reflected upon or about this line. So for us to have a mirror image, all right, for us to have a mirror image of point B, it means that we must just swap the coordinates of B. X becomes y and y becomes x. Then you are done in that way. So it means that the reflection or the image or the reflection of point B, let me write it down. The reflection of point B which is 2 is to 0, it now becomes 0 is to positive 2. So in order for us to have a reflection, we just have to switch the coordinates about that line. Y is equals to x plus 2. So the image of P will be the same distance from the axis of symmetry as B, but in the opposite direction. So what we had to do in this question was just to exchange or to swap the coordinates. X becomes B, x becomes y, and then y becomes x, and then you are done. I hope it makes sense. So don't forget to like, share, and subscribe to the YouTube channel, guys. So see you in the next session.